Okay, so this is 2022 ADDMA paper 1 question 11. I'll quickly solve this one using the expansion method. I know you can solve this by using the u substitution by letting this entire thing be a u, but I think using the expansion method is much easier. This is my target for this tutorial. So we have the integral from -1 to 2 of 3 minus 4x to the power 3 dx. So we can expand this using this expansion. This one will be like a to the power 3 minus 3 a squared b minus 3 actually plus 3 ab squared then minus b to the power 3 when you expand this. So using this we can expand that. Of course you are free to use the binomial theorem. So 3 minus 4x to the power 3, this is like 3 to the power 3 minus 3, and then we can say 3 squared 4x, the negative is already here, then plus 3 4x squared, and then minus 4x to the power 3, the negative is already here. So this is 27, and then this is 3 squared times 3, that's 27 again, multiplied by 4, this is 108x, and then 3 times 3, that's 9, multiplied by 16, that's like 144 x squared, and then 4 to the power 3 is 64 x to the power 3. So we are integrating this with respect to x from -1 to 2. So you can say the integral from -1 to 2 of 27x, no, not 27x, 27 minus 108 x plus 144 x squared minus 64 x cubed with respect to x. So when I integrate this, I should get 27. Remember, we have an invisible x to the power 0 there. This will be 27x, because you just add the power, a 1 to the power or to the index or to the exponent and divide by the same. So when I add the 1 to this, I'll have x to the power 1, then I divide by 1, it won't change anything. So this one will be 108x, this one will increase by a 1, we have a 2 as a power, you divide by 2, then plus 144x, this one will increase by 1 as well, divide by 3, this will equally increase by 1 so that it becomes a 4, that is 3 plus 1 is 4, then you divide by the same power, then you're integrating from -1 to +2. So this one remains the same, 27x. 2 into 10 is 5, 2 into 8, you have a 4 squared, plus 3 into 14 is 4 times, remainder 2, 3 into 24, that's an 8 x cubed, and then 4 into 64 is 16 x to the power 4. Then at this point you can simply find f of 2, this one, minus f of -1, this one, where f is this thing here, capital letter F. So we can say 27, where there is x you put your 2 minus 54, 2 squared plus 48, 2 cubed minus 16, 2 to the power 4, then minus 27, negative 1, 54, negative 1 squared, 48, negative 1 cubed, minus 16, negative 1 to the 4. Then we can evaluate. So 27 times 2 is 54. And then this is 4, and then 4 times 4 is 16, so you can write the 6, and then 4 times this, that's a 20, 4 times 5 is 20, plus the one from this, from 16, we have 216. I think we should have the x is gone. Then this is 2 to the power 3, that's an 8. Then 8 multiplied by 48, getting 384 from my calculator. 48 multiplied by 8, and then minus 16 squared, that's 216. Because this one to the power 4 is 16. 16 times 16 is 216. So let me just verify that. 2 raised to the power 4. Actually 256. 256. Then minus this times this is negative 27. This, because of the square, this will be 54. Because of the 3, this will be negative 48. Because of the even power, so when the power is even, you expect this to be positive. So that means it won't have an impact on this. And then next we can add. So I'll just quickly punch all these numbers on my calculator. So I have 54 minus 216 plus 384 minus 256. So this is giving me negative 34, and then minus, we have negative 27 minus 54 minus 48 minus 16. This is negative 145. And then when we add these two, because this is an addition there, when we add 84, we have 111, and that's your answer for part A. So now let's move on to part B, which is my point of interest. So on part B, we have the diagram shows part of the curve y is equal to cos x. So remember, the cosine wave starts from here and then it will form a wave like that, intersecting the curve y is equal to sine theta. This one here, which will go something like this at P. So find the coordinates of P. To find the coordinates of P, you simply solve these two equations simultaneously, as you may have guessed. So you can say cos theta is equal to sine theta. So you can divide both sides by cos. Remember that when you have something like this, there is nothing you can do since you have unlike terms. So you want to make the terms alike by taking advantage of the fact that tan theta is equal to sine theta over cos theta. So if I can just divide both sides by cos theta, then I'll have a tan theta this side, So now to find my theta, I can simply introduce can say tan theta is equal to arc tan 1. You may not even need the alpha here because you know what is expected here. I mean, this is like 0, and then this is 180, and then this is 360 somewhere at the end there. So you know that actually this should be 90. Let me see. Yeah, this should be 90. So you expect to have a 45 degrees somewhere. So now when you punch this on your calculator, this is a well-known thing. Sorry, I meant to say tan inverse. So the inverse tan of 1 is 45. As you can see, make sure that your calculator is in degrees because we are dealing with degrees here, I think. So this is 45 degrees. Actually, we should be working in radians, not degrees, because this is calculus. So in calculus, we don't use degrees. So if I was to convert this to degrees, this would be pi, and then that. So this one there is 4. So our theta is pi over 4. So that's the x coordinate of this point. Then to find the y coordinates, you can use any of these two. So you can say, I'll use this one. Y is equal to sine pi over 4. So now using my calculator in radians, I can say sine pi divided by 4. This is y is equal to, of course you can find this one using the triangular method so that you have the exact value of this, but I've decided to use my calculator anyway. So the coordinates of that point P will be pi over 4 comma 0.7071. This number is actually like 1 over the square root of 2. So you can even have your answer as pi over this if you want to write the exact coordinates of this point P. So these are your coordinates if you were to use the triangle method. And then the area of the shaded region. So to find the area of the shaded region, you can integrate this function with respect to theta from 0 to this point here. Remember this point is pi over 4. So you can say area is equal to the integral from 0 to pi over 4. This is the bigger area. So this will give us the area below this curve. We have, of course, theta, the theta, and then you can subtract the area from 0 to pi over 4 of this function here, which will give us the area below this. So once you subtract, you have the area of the shaded region with respect to theta. So now this is where you have to know how to integrate trigonometric ratios. So the integral of sine x with respect to x is negative cos x plus c. Do not forget this c. And then the integral of cos x dx will be sine x plus c. So now using this, we can evaluate these two. So this is like the integral of cos theta. Of course, you can combine them. Let's do that. You can combine these two since they have the same limits of integration. So you have cos theta. Just make sure that you include the brackets. So we can say the integral of cos theta is sine. Remember that. This one will simply be sine theta. You don't need to write the constant because we have limits of integration. Then the integral of sine is cos. Of course, it will be negative cos x. And then you are integrating from 0 to pi over 40 over 4. So this is like sine theta plus cos theta. Of course, this is theta from 0 to pi over 4. And then when I substitute this into this, I'll have sine pi over 4 plus cos pi over 4, then everything minus sine 0 plus cos 0. So these are well-known angles. Sine this is 0.71, 707 something, which is just 1 over the square root of 2, but I'll punch it on the calculator anyway. So this one will be like this. Let me just add the brackets. Sorry. Sine pi divided by 4. So we are getting this 0.7071 plus, it's just the same as this. You can even verify that. So even if I punch in cos the same angle, I'll get the same thing. So 0.7071. And the reason is very simple, because we have 1, and then 45. I'm just using degrees. So when I say cos 45, I mean 1 over this, and then when I say sine 45, it's 1 over that. So at this, with this angle, all the two ratios are the same, sine and cosine. And then sine 0 is still a 0, cos 0 is 1. And then when we add these, we get something like 7 plus 7. This one will be 1.4, another 1.42, something like this. Just verify that. 1.414, yes. Then minus 1. So when we subtract this, we get this as our area. So we can end here.